Hello guys, today actually I want us to deal with beams, and I think these beams normally that we're gonna be dealing with is actually for N1, N2, N3, well, and let's say maybe to an extent N4, because somewhere somehow we're gonna put some uniformly distributed load and so on, which I think are meant for N4. But for a beam, to say that thing is a beam, it must actually satisfy three conditions. And one of those conditions is what? Is that the sum of the upward forces is equal to the sum of the downward forces. Normally from the engineering point of view, that's how we write it. And then number two, we must say the sum of the horizontal forces is equal to the sum of the horizontal forces, say to the left is equal to the sum of horizontal forces to the right. Let's say for instance this is right. And then the last one, it should say the sum of the clockwise moment is equal to the sum of the anti-clockwise moment. Well, we're gonna give an example. Practically speaking, let's say this is a beam. Normally for this level N1, N2, let's say this is a simply supported beam, and then let's say for argument's sake this beam, it's supported at both ends. These are supports. Normally in the exam are referred to as the reactional support. And then let's say for instance we have a force here. Normally a force that is acting downwards, let's say for instance it is 40 kilonewton. Because of its acting downward at this point, we call this force normally a concentrated load or a point load. And then let's say for argument's sake the distance from here to there is 2 meters. And then let's say for instance we got another point load here. It's a point load. Why? It's acting, it is applied at one point, and let's say for argument's sake it is 60 kilonewton. And then let's say the distance from here to there is 4 meters, and then say for instance it's too long, this one. Say for instance also the distance from here to there is 2 meters, and then the distance here it is 2 meters, and this is the reactional support. Let's say the reaction at B, and then it is the reaction at A. Basically in the exam you will be given this like this, and you have to calculate the reaction at the support. And if you calculate the reaction at the support, you have to take moments, or your calculations should satisfy these three conditions, otherwise your beam is wrong. Now let's see. For instance, this is a 10-mark question, and we will say the moment at, you can start at any point. Let's say at A here. Normally I prefer A because normally we work from left to right in engineering. That's why we'll say A. But you can also start to say the moment at B. The moment of B. What about the moment at B? It means all your forces are going to B. Are going to A. And if they are going to A, it means you calculate the reaction at B. If you say moment at B, then you are calculating the reaction at A. So the moment at B, we calculate the reaction at B. Let's start. Its moment at A the sum of the clockwise moment is equals to the sum of the anti-clockwise moment. Because of you are familiar with this count 1 in itself, but it's a discussion for another day. But at least you are giving, you are solving this problem as if you are discussing with your lecturer. You are telling you are telling him that you took moment at A, and for that moment to continue, you are telling him then you're gonna take the sum of the clockwise moment is equal to the sum of the anti-clockwise moment. It means you are telling him that all forces are going to A, and the clockwise moment should be equals to the anti-clockwise moment. Now let's start with the clockwise moment. By clockwise moment I mean what? Forces are going to A. By clockwise moment actually we mean a watch. A watch goes clockwise. It's a clockwise moment. Now, for this, the forces, how will the forces go? It will be something like this. It's clockwise. And normally I prefer that you start with the one close to A, so that you shouldn't confuse yourself. Now, let's say the force. The moment is force by distance. So it's force 40 multiplied by the distance from 40 to A, which is 2 meters, plus this force, which is 60. Why 60? Because it is also a clockwise one. It is 60 times the distance from 60 to A is what? Is 4 plus 2. This time is 6. Ne? Is equals to, there is no any other force. That is why hence equals to. Now, is equals to what? The anti-clockwise one. The way in which the clock is not moving. And it is RB times the distance from here to A. It is the sum total. It is the distance, the total distance of the beam, which is 2, 6, 8. And it is 8. 8, yes, 8. Now, a simple mathematics. A simple mathematics will be 40 times 2 is equals to 80, plus 60 times 6 is equals to what? I think it's 360. 6 times 6 is 30, yes, it's 360. Is equals to 8 RB. Now, 360 plus 80 is equals to 440, equals to 8 RB. And then if you divide both sides by 8, you must get the reaction at B. Therefore, RB is equals to what? I don't have that one. Unfortunately, I can't do it. Where's my calculator here? Let's see. I've got my calculator, and it's 440 divided by 8, and it is equals to 55. It's equals to 55. It's equals to 55. This is the reaction at B, which is 55 kilonewton. This is very, very important, guys. I would have liked to start with units, but unfortunately someone in passing told me that looks like so we've got only 7 weeks to prepare. Just do anything, especially with the most chapters that give what is so-called a throw-in to the examination, like beams, hydraulics and stuff. And then, but at times, somewhere we will touch units. The reason why this 55 is in kilonewton, it is because of your beam was given in kilonewton. That's why it is in kilonewton. But if you say the answer is 55 newton, it's wrong because you are working in kilonewton. Like I said, you can call me Tekiso. Van Strayer is my surname. We're gonna try and discuss myriads of engineering problems on field, schoolwork, and so on. And because of we're gonna provide, I'm not alone here unfortunately, but we're gonna provide and make a research and provide a proper information to you. With due respect, man, we will like, and please help us maybe to grow this channel by subscribing, and all. We're also gonna leave an email for you if you want to comment or leave us to other problems you think we might discuss and so on. Yeah, for now. But this is the answer for this one. And remember, guys, this is actually this is a 10-mark question, so you are only at 3 marks. This is engineering. Don't just look at the steps. Now then, that write this 55 somewhere, and I hope, and then let me erase. Now then that we've got 55, you also have to find the reaction at A, because you got the reaction at B. Now it was the moment at A, now it's gonna be the moment at B. The sum of the clockwise moment is equal to the sum of the anti-clockwise moment. Now the clockwise ones, remember now guys, we are now heading to B. The clockwise ones is what? RA is clockwise, meaning it's gonna be RA times the total distance of the beam, which is 8. And there is no any other force heading upwards. Now it's equal to, for that reason you put equal sign, because there is no any other force that is clockwise. It's equal to what? It's equal to the anti-clockwise moment. It is this force which goes anti-clockwise, which is 60 times the distance from 60 to B is 2, plus this one, which is 40 times the distance from here to there is 4 plus 2, which is 6. And that's it. And then you've got 8 RA is equal to 60 times 2, guys. Yeah, I think it's 120. Your mental is very, from grade A or sub A or grade 2. That thing that your teacher used to say, hey, every morning say 2, 4, 6 up to 120 and so on. Now it comes into play. Plus 40 times 6, guys. 40 times 60 is what? It is 40, 80, 120. 120 plus another 120 is 240. 240. And then it's equal to what? 8 RA is equal to 120 plus 240. I'm expecting roughly 360 as well. 360, yes, 360. Therefore, if we make RA subject of the formula, you're gonna end up with 360 over 8. And it's equal to what? It is equal to, say, 360 divided by 8. And it's equal to 45 kilonewton. This satisfies condition number 3. Your reaction satisfies condition number 3. You still have to prove with the remaining 2 conditions. Now let's test that indeed this is the case. 45 plus 55. Let's say it's 45 here. Now test. You've got another 3 marks. That's 6 marks. You are left with 4 marks. Now test. If we test, the sum of the upward forces must be equal to the sum of the downward forces. That's condition number 1. Let's see. What are the upward forces? The upward forces are only the reactions or the supports. And it's equal to what? It is 45 plus 55. Is equal to the downward forces. It's equal to the downward forces, which is 40 plus 60. Therefore, 100 kilonewton is equal to 100 kilonewton. Therefore, indeed, RA is equals to 45 kilonewton and RB is equals to 55 kilonewton. You can end it there and you've got your 10 marks overall. You got your 10 marks. You can also prove condition B whether it's hold. Remember we say the horizontal forces to the left must be equal to the horizontal forces to the right. Let's check. The horizontal forces to the right, it will be what? It will be, okay guys, I hope you have already jotted this one down. I just wanted to show you something. Now guys, I just wanted to show you something with regard to condition number 2. This is 45 minus 40 is equal to what? Is equal to 5 kilonewton. And this one is how much? Is 55? Is 55, or let me put it this way. Let's say it's 60 minus the upward forces of 55 is equal to 5 kilonewton.